Welcome to the making of a real-time strategy game, Part 7. Previously, we made an electrical grid, a truck logistical system, robot flocking and aggro, more weapons, an economic system, and an attempt to make the AI. Last video, Part 6, the game was progressing slowly since I was trying to figure out the game and make the AI at the same time. There were too many missing parts at the point to start on the AI. In this video, I do a set of mini projects to move the game forward one step at a time. Minerals are added to the game. The drill mine building is added to mine the minerals. The look of the minerals is created with a shader in Blender. Let's see how it is done in Blender. First, create a cylinder, make it 10 units high. Then create a material and switch to the shader viewport. We need to duplicate the color and connect both of them with the mixer. We need an input for the mixer, extract the geometry node, separate the X, Y, Z. We only want the Z, which is the height. Map the range. The cylinder in this case is 10 units tall. We want to map between 0 and 1 for the range of 0 and 10. Put the output to the mixer. Now you could change both of the colors to get the look desired. The bases now have settings to send out patrols that you could change in the map editor. I also added a way of altering it during the game for testing. This isn't quite how it works in the final game, but it is a step in the right direction. The trucks now use power from the batteries to move. At this point, it is realized that controlling the amount and the mining rate of minerals in this game is key to balance the player's ability to generate offense. What does the player need to build tanks? Well, they need batteries. What do you need to build batteries? Minerals. Robots now have a beating heart. In a lot of RTSs, there are bars over the units to show hit points. I realized it would make more sense to have all the models be as visual as possible. That is, give all the information to the player you can in the model itself. So I did this with the robots so they could show their hit points by changing the color of the heart. Since multi-mesh does not allow for any animations, just shaders, having something that moves makes the model look more alive versus static. The shader code is simple. First, place the heart at 0, 0 by using the known height of the heart, apply the scale, and then put the heart back in its proper height. Mix the color from green to red, given the percentage, while of hit points sent to the shader. In the code, each robot has a child physics process. In it, the heart is either expanding or contracting depending on the phase of the cycle. The information is sent to the shader using the shader's instance custom. There are 4 floats the developer has access to in the multi-mesh to send over information for each instance of a robot. Note that this is not the normal way to do this. Usually you use a Godot built-in functions, but those are found to be too slow. A following video will explain this. The model of the transmission tower, which is one of the original models so far, is improved. A power connector is placed on top. Eventually, all the buildings will have this power connector, and it's not only used for the game to know where to link the power cables, it's also used to display the state of the transmission grid. Obviously, green if it's going well, red if the power is off. The silo model is significantly improved from the previous one. It is decided it will be the only storage building in the game, so I decided to add all the storage capabilities, such as core and hemp, all the crystals in the front of it. The tow truck is improved to have a procedural animation for the tow boom. It both improves the animation and allows the boom to be extended to any length. The tow truck also gets a release tow button. And the code is similar to the construction crane in that there is a state table and the boom is controlled in the physics function. The color of the laser tank is changed from green to blue for 2 reasons. The first is green is the color of the ground, and it blends in too well with the ground. The other is I wanted for the laser tank to show the percentage of battery charge in it without needing a power bar or something. And I did this by setting one of its materials to going from green to red to show discharge. So if it is green and the tank is green, well, you won't be able to really tell what's happening. The code to do this is very simple. It is easy to access the color of a material and simply altering the color. One important thing to know is when doing this, the material resource needs to be set to local to scene. Otherwise, all the tanks will share the same color and will conflict. If one tank is discharged at red and another one is green, that will cause the material to flash between red and green. The tree depot now has much better animation, and also not seen is that the pump also spins. This is a procedural animation in the code, not a Blender animation. It is decided that each level the fruit upgrade would cause the amount of fruit and the amount required for the weapon upgrade to go up by a factor of 5. This would allow one further weapon upgrade if enough fruit is banked. It would also allow 5 times as many lower level weapons to be created if required. Say you have a tree at level 2 and you're building a ton of towers, you could use a ton of level 1 lasers. This is later hidden for display purposes, but is still how it works internally. There is an option to view the game in minimap format or an overhead cam that shows the entire map by pressing M. The camera location can be controlled by clicking on the map, and you could toggle between the minimap and the normal map to very quickly navigate around the map. HUD alerts are added to notify the player of events, such as a truck running out of battery. Having 2 cameras in the code is pretty easy. So you're going to need two Godot cameras basically in the scene, and then you could simply toggle between them. If you abstract that into a single camera, as I do, the rest of the game doesn't need any changes. Looking at the viewport window, middle left, you can see when an item is built in a factory, the model is now shown in the animation. This uses the same code as a building truck and placing miniature models of any object on the screen. There is one more power plant in the game now called the biomass, and this uses a drop system. So biomass can be placed on the map for the vacuum to pick it up. It can be protected by robots. The biomass plant is designed to generate more power than any of the other power plants, but have a limited amount of fuel. An interesting note of the development of the biomass power plant, it took half a day of staring at power plant pictures before I decided to use a model of a steam train instead. What I really wanted was something to be shoveled in and there'd be a massive fire. And when I looked at the steam train, I was like, oh, that may work. Then after looking at the steam train, I realized that I also want the pistons and the wheels, and I want the wheels to be electrical generators. I couldn't quite figure out how to do that, but then I realized I could just avoid doing the rest of the steam train, like the water tank and so on, and then I was able to figure out how to do the model. It took far longer of thinking how to do the idea than how to make the model. It took even less time to code the model since it reuses building code. This is a good example of how resolving an idea takes more time than to make the model. It takes even less time to write the code since it reuses all the building code. If you're wondering why it sometimes takes a day or days to make new things, the implementation is the easy part. The concept is the hard part. The fields are now renewable. They will regenerate their resources in time. An interesting thing with this clip is that you can now see a cliff. I got those models from a Cinti pack. That pack gives several different pieces, which can then be used to make any arbitrary geometry. I didn't use these cliffs in the game, but I made similar ones myself. I was thinking in Warcraft 3. In that game, there are creep camps and they are placed in front of something they are guarding, and usually only accessible from the front. I originally thought to do this in this game, but I felt it doesn't make that much sense since the map is supposed to be a garden. I realized an obvious solution would be that the vacuum truck cannot gather items if they are currently being guarded by robots. I call this a dampening field. This also prevents the player from building towers up to a main base. I realize flocking isn't going to work in this game for trucks. When exiting a building, the truck would flock with the other trucks at the exit. As you can see, this doesn't look that good. I later developed another way to do this. I added cockroach robots to the game. What you see is an early model without the moving legs. These robots are anti-area effect, that is, the multi-shot and the artillery do reduce damage. The joke is as the battle goes on, the only robots left over are the cockroaches. Potash is added to the game as it is realized that having only one mineral type for both batteries and tree upgrades would cause too many conflicts. The potash is used to fertilize and upgrade the trees. It is the same model as the minerals with a different color. The delivery truck is improved from the original model to a new one. The storage size of the delivery truck is also increased by 5 to simplify the logistical system. The model is nearly the same as the water truck since that model was done properly. Perhaps it seems that the progress is slow, but this is due to the time it takes to come up with concepts. Coming up with ideas takes far more time than the implementation. Also, I generally only show milestones in these videos. There are many days spent on doing code fixes. Upon reflection of this video, I was correct to move forward in any way possible. Rather than just work on the AI and hope I would get a game out of it, I made some simple maps, tested individual mechanics, added, improved, and fixed things to make the game playable. The game is still not ready yet for any real map creation, but it is getting closer. Thanks for watching.